An inscribed angle is an angle with its vertex on the circle with two sides that are chords. And then there's an example here. So we have two chords that meet at angle B, and that is your inscribed angle when it's on the circle. An intercepted arc is the arc that lies between the endpoints of an inscribed angle. So here's the endpoint A and endpoint C. My inscribed angle is this angle, or this arc here. I'm sorry, the intercepted arc is from here to here. The degree of the inscribed angle is equal to half the measure of its intercepted arc. So here we have the measure of angle ABC. ABC. It is half the measure of arc AC. So to put that into practice, in part A, if I was given that arc WY is 62 degrees, then you would just divide that by 2 to get angle WXY. So 62 divided by 2 gives me 31 degrees. In part B, to get the arc DGF, I would just double this. So 113 times 2 gives me my entire arc, and that is 226 degrees. In part C, we do arc J to L. We can add these together, and if we subtract that from 360, we get that this arc here is 242 degrees. If our goal is to find angle JKL, this angle here, divide that by 2. Part D. So for this one, I would say, okay, the angle equals 158 divided by 2. So the arc, we would divide it by 2 to get the angle, but we don't know the exact angle. We know that it's this expression, 8x minus 9. Now if I divide this, I know that that angle is 79, but it still tells me I need to find x. So if I add 9, we get 88, and if I divide by 8, we get 11. Now down here at this section, it has different corollaries, and then how it's worked out is like this corollary will go with these 3 examples, and then corollary 2 will go with the bottom 3 examples, so forth and so on. So the first corollary says, if 2 inscribed angles intercept the same arc, then the angles are congruent. And that the measure of angle ABD is the same as the measure of angle ACD. Now, it might be easier to see this in some highlighters. Okay, so, for example, if I had to look at ABD, here's ABD, and ACD, I see that both of the endpoints for the yellow and the green end at A and D. So this arc is the same. That means that these angles are the same. Okay, so if this was like 20 and 20, you would double those to get AD to be 40. Okay, if this is 40, you would divide by 2 to get that's 20 and that's 20. The big idea though is that these are congruent because they have the same endpoints, A and D. Okay, in corollary 2, it says if an inscribed angle intercepts a diameter, okay, here's your arc, here's your angle. Your ends are at B and C, which is at a diameter, okay, then it is a 90, or a right angle, and that the measure of angle BAC is 90. Okay, and if you think about the math behind it, it makes sense. from from arc B to C, this is 180, and a half of that is 90. So this right here is 90. Okay, last corollary. It says, if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So we would say angle A and angle C, if I add them together, I get 180. So the measure of angle B plus the measure of angle D is 180. Alright, so to put this in use, corollary 1, we're going to go back to this one. Okay, if I am looking at angle 2, that's what I have to get. I see that this right here has the same exact endpoints. Okay, it might be easier seeing green. Okay, they have the same endpoints. So if this is 38, then this is 38. They're both 38 degrees. Okay, for here it says find the measure of angle RST. Okay, and so what I would do is I would do 360 degrees minus the sum of all of these arc measures. I would add these up together and subtract that from 360. And if you do that, you get 278. And then we subtract, we get 82. So this arc, RT, is 82. Now, because RT is my arc intercepted by this angle, I take half of 82 to get that this is 41. Then it says find RUT. RUT is right here. If you notice, the endpoints are exactly the same. So again, that's half of 82, which is 41. These are congruent angles because they have the same arc. Okay, and then lastly, for this corollary, if the measure of angle ABD is 6x plus 26, and the measure of angle ACD is 13x minus 9, find the arc measure AD. And so as I can see, my endpoints again are A and D. Okay, they have the same arc, which means their angles are congruent. So I would just set these equal to each other to solve for x. Okay, so now if I add 9 over, we get 35, and x is 5. To get the measure of AD, I would need to plug the 5 into one of these expressions and then double that, because this represents the angle measurement. So if I were to plug it into 6x plus 26, that's 6 times 5 plus 26, and that would be 30 plus 26, and 30 plus 26 is 56. Okay, but if 56 represents the angle measure, I double that and get the arc. So this arc is 112 degrees.